be wrapping up chapter 5 with section 4 half-angle formulas. So first I'm going to show you the derivation for these formulas, and they come from using both versions of the cosine double angle identity. Okay, so first of all, we're going to start with cosine 2u equals 1 minus 2 sine squared u, and my goal is to solve for sine u. So I'm going to add the 2 sine squared u to the other side. And then I'm going to move the cosine 2u to the right-hand side of the equation. So then I have that equals 1 minus cosine 2u. And then I want to solve for sine u, so I'm going to divide everything by 2. So I have sine squared u equals 1 minus cosine 2u over 2. And then to solve for sine u, I need to take the square root of both sides. Don't forget, put plus or minus here. So then we have sine of u equals plus or minus the square root of 1 minus cosine 2u over 2. Okay, then from here, what I'm going to do is let theta divided by 2 equal u. And so everywhere that I have a u, I'm going to replace that with theta over 2. So what that leaves us with is sine of, not u, but theta over 2 equals plus or minus the square root of 1 minus cosine. Now 2 times theta over 2 is just going to give me theta all over 2. So that's the first half-angle formula for sine of theta over 2. Okay, so theta would be the angle that you typically is known from the unit circle, or a common angle, and theta over 2 is the one that you're trying to figure out. Whether or not it's positive or negative depends on the quadrant in which theta over 2 is. Okay, so keep that in mind when you're trying to decide at the very end, or you can decide up in the beginning of the problem, depending on the information that's given, whether or not you're going to use the positive or negative. Okay, now let's see how we get the other half-angle identity for cosine. Well, we're going to use the other version of our cosine double angle identity. And again, I want to solve for cosine u. So I'm going to add the 1 over to the other side, and then I'm just going to reverse my equation. So I'm going to have 2 cosine squared u equals 1 plus cosine 2u. And then same as last time, we're going to divide everything by 2. So we'll have cosine squared u equals 1 plus cosine 2u over 2. So cosine of u equals plus or minus the square root of 1 plus cosine 2u divided by 2. And then similar to last time, we're going to let theta divided by 2 equal u. So everywhere there's a u, I'm going to replace that with theta over 2. So cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta over 2. So I would say the key thing to notice when you're memorizing these formulas and working with them is that the cosine half angle in the numerator, it has a 1 plus cosine theta, and the sine half angle has a 1 minus cosine theta. But they both have that 1 and cosine theta divided by 2 underneath the radical. Okay, so we're going to be working with these. When you get to calculus, you're going to be working with the version of the half-angle identity that comes from before you take the square root. So you're going to be working with them more commonly at this step here when you're in calc, right before we took the square root of both sides. Okay, so that's what you see here. So you'll use those a lot in Calc 2. And then for tangent, we won't go through the derivation. There's 3 different versions. You can really use whichever one you like. I will say this. This one's typically easier to work with when you're cleaning it up or simplifying, in case you need to rationalize the denominator or something, because it only has one term. okay? But in the end, once you simplify everything, you'll get the same answer. So it doesn't matter which one you end up memorizing. Just pick one and stick with it, I guess. All right, so here we go. Example 1, find the exact values of sine of theta over 2, cosine theta over 2, and tangent theta over 2 for the given conditions. So first thing they tell me is that theta is between 180 and 270, and that secant of theta is -4. So I'm going to right away rewrite this piece of information. That tells me that cosine of theta is -1/4, right? The reciprocal. And theta is between 180 and 270. So theta is in quadrant 3, but I'm not interested in theta. I want sine of theta over 2, cosine of theta over 2, tangent of theta over 2. So what I'm going to do is divide this whole inequality by 2. And now I have 90 degrees is less than theta over 2 is less than 135 degrees. So let's see here. If theta over 2 is between 90 and 135, and which quadrant is it? So between 90 and 135, we're in quadrant 2, okay? All right, so here we go. Sine of theta over 2. Let's decide right now. Is sine going to be positive or negative? Well, since we're in quadrant 2, all the y values are positive, so sine's going to be positive. And then I have the square root of 1 minus -1/4 over 2. Okay, and then that's going to give me the square root. Now it's 1 plus 1/4 over 2. So 1 plus 1/4, that's 5 over 4. So I have the square root of 5 over 4 over 2. So that's the square root of 5 over 8. I'm going to split up the radical. That's square root of 5 over square root of 8. Square root of 8 is 2 rad 2. And then I need to rationalize the denominator, multiply by rad 2. So we have rad 10 over 4. Okay, very nice. Next one, cosine of theta over 2. Now let's decide, is cosine going to be positive or negative? Well, we're in quadrant 2, the x values are negative, so cosine's going to be negative. So I'm going to have a negative sign sitting outside, and then this is going to be 1 plus cosine of theta, -1/4 over 2. So this is negative radical 1 plus a -1/4. 1 minus 1/4, that's 3 over 4 over 2. So this is negative square root of 3 over 8. So that's negative rad 3 over 2 rad 2. And then again, we're going to rationalize. So I'm going to multiply by rad 2. And then this gives me negative rad 6 over 4. Because this is a 2, right? Okay, very good. Come back. Now, last one is tangent of theta over 2. So you have a couple options. You could just do sine of theta over 2 divided by cosine of theta over 2, or we could work with the formula. So it's really up to you. Since I didn't draw a triangle though, I don't really feel like working with the formula because I would need sine u, and I'm only given cosine of the angle right now. So I'm just going to take sine of theta over 2 and then divide it by cosine of theta over 2. So that's rad 10 over 4 over negative rad 6 over 4. The 4's cancel. And then this is going to give me rad 10 over rad 6, and it's negative. And then to simplify, let's see here. Well, I can write this as negative rad 10 over 6, which is negative rad, I can divide out a 2 5 over 3. So that's negative rad 5 over rad 3. And then we rationalize. And final answer is negative rad 15 over 3. Okay. Lovely. So hopefully those weren't too tricky. Now moving on, one more example, and in this case we are going to have to draw a triangle. So find the exact values of sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. So they tell me that sine of theta over 2 is negative 1/3. And theta over 2 is between 7 pi over 4 and 2 pi. So that's quadrant 4. Okay. Now, in this case, this is a little weird. They gave me theta over 2, not theta. So if they want, for example, sine theta, I'm actually going to use the double angle identity because sine of theta is sine of 2 times theta over 2, right? It's double what they gave me. And then if I use my double angle identity for sine, that would be 2 sine of theta over 2 times cosine of theta over 2. So I'm in pretty good shape because I need sine of theta over 2, which they gave me. The only thing I'm missing is cosine theta over 2. So that's why we're going to draw a triangle right now. So I know theta over 2 is in quadrant 4, so we'll put our triangle there. X-axis, y-axis. So here's theta over 2, and they told me sine of theta over 2 is negative 1/3. Okay, so that means the opposite side, that's going to be negative 1. The hypotenuse is always positive, that's 3. And then let's figure out the missing side here. Well, that x squared plus negative 1 squared is equal to 3 squared. So that means x squared plus 1 is 9. So x squared is 8, and it's going to be positive. So x equals the square root of 8, which is 2 rad 2. So I'll label that. That's 2 rad 2. Okay, and then now we can go ahead and figure out what all the values are. So I have 2 times, now sine of theta over 2, that's negative 1/3. And then cosine theta over 2. So cosine theta over 2 is going to be the adjacent side over the hypotenuse. So that's going to be 2 rad 2 over 3. All right, let's see. Does anything cancel out? No. So we're going to have negative. Now, the 2 times 2, that's outside the radical. So that's going to be 4 rad 2 over 3 times 3 is 9. All right, beautiful. So now I need cosine of theta. So cosine of theta, again, I have to use the double angle. So that's cosine of 2 times theta over 2. And you can use whichever version of the cosine double angle identity that you like. I usually just stick with cosine squared of theta over 2 minus sine squared of theta over 2. And then we already found this right in the previous problem. So cosine of theta over 2, that's the adjacent over hypotenuse. So I have 2 rad 2 squared, or actually, do you remember? Before we cleaned it up, it was rad 8. That's going to be easier to square. So this is rad 8 over 3 squared minus sine of theta over 2 they gave me. That was negative 1/3 squared. So rad 8 squared is 8 over 3. That's 9. So 8 over 9 minus, and then this is going to become a positive 1 over 9. So this is 7 over 9. All right. Beautiful. Now the rest are going to be easy peasy. So tangent theta, that's sine theta over cosine theta. So that's negative 4 rad 2 over 9 over 7 over 9. So the 9's cancel. And then I'm just left with negative 4 rad 2 over 7. Okay, no big deal. Cosecant theta, that's the reciprocal of sine, so that's going to be negative 9 over 4 rad 2. I have to rationalize that. So multiply by rad 2. So we'll have negative 9 rad 2 over, now this is going to give me a 2. 2 times 4 in the denominator is 8. And then secant theta, that's the reciprocal of cosine theta, so that's just 9 over 7. And last but not least, cotangent theta. So cotangent theta is the reciprocal of tangent. So we have negative 7 over 4 rad 2. Again, I have to rationalize. So multiply by rad 2. So this is negative 7 rad 2 over, this is 2 times, rad 2 times rad 2 is 2. So I have 8. Woohoo, we made it. So in this case, you actually use double angle identities, but it was in disguise a little bit, right? Okay. Last two examples are doing identities with the half angle formulas that we just went over. Okay, so verify the identity. Let's pick a side to start with. I think the left-hand side looks messier, and I already see x over 2, so maybe we can use our half angles in some way. So we'll start with the left-hand side. Since I have this quantity squared, why don't we expand it? Okay, so I'm going to square the first term. So I have sine squared x over 2. And then remember, when you square a binomial, the middle term matches the sign that you see there. So it's going to stay minus. And then I have 2 times sine of x over 2, cosine x over 2, and then always plus the last term squared. So cosine squared x over 2. All right, well, let's see here. I have a sine squared and cosine squared of the same quantity. So anytime you have sine squared plus cosine squared, that's just 1 minus 2 times sine of x over 2 cosine of x over 2. And then, does this look familiar? 2 times sine of something cosine something. That's your sine double angle identity, right? So I can replace that with 1 minus 2, or no more 2. Now it's sine of 2 times x over 2. And then we're basically done because this is 1 minus sine of x. 2 times x over 2 is x, and that is the right-hand side, people. So that one's done. All right, last one. Tangent of x over 2 equals 1 minus cosine x over sine x. This is actually one of the versions of the tangent half angle identity, so we're just proving it. So let's start with the left-hand side. So we'll work with tangent of x over 2. So what I'm going to do first is rewrite this as sine of x over 2 over cosine of x over 2. And then now I'm going to replace them with each of their appropriate half angle identities. So sine of x over 2, remember we have plus or minus, square root of 1 minus cosine x over 2 over plus or minus square root 1 plus cosine x over 2. And then I can split up the radical over the numerator and denominator. So I have rad 1 minus cosine x over rad 2 over rad 1 plus cosine x over rad 2. Ooh. And then we can just cancel those plus or minuses for now. The rad 2's are going to cancel out. So then, continuing up here, I have rad 1 minus cosine x over rad 1 plus cosine x. Now what I want to do is multiply numerator and denominator by rad 1 minus cosine x. Why do I want to do that? Well, what I want to do is end up with 1 minus cosine squared x underneath the radical. That way I can use my Pythagorean identity to simplify. So in the numerator, if you have rad 1 minus cosine x times rad 1 minus cosine x, I'm just going to be left with 1 minus cosine x, right? Over square root 1 minus cosine squared x. Remember, 1 plus cosine x and 1 minus cosine x are conjugate pairs, so I get a difference of squares when I multiply them out. And then this is 1 minus cosine x over the square root of sine squared x, which gives me 1 minus cosine x over, technically it's absolute value of sine x, but we've kind of been ignoring the plus or minuses for now. So we'll just leave it there. And then we're done. So that's the right-hand side. Woohoo! All right, so that's it. We're actually not going to cover 5.5. It's optional. So these are all your lectures for the week.